Good day. My name is Miguel from the Salle University, Manila. This work is joint with my co-authors Anton Vale and Gabriel De Jesus, under the guidance of our advisor, Sir Nathaniel. Today I'll be presenting our poster paper entitled A Rule-Based Filipino Spelling Checker for Aligning with the National Agency's Guidelines. Filipino spelling inconsistencies remain a persistent challenge, especially in formal and academic contexts. Although Filipino is one of the Philippines' national languages and spoken by millions worldwide, this remains underrepresented in NLP. This means high quality tools are lacking for research, education, and everyday applications. The Comisión sa Wikang Filipino, or KWF, is the government agency mandated to preserve and promote the national language. However, current NLP tools do not strictly follow its orthographic rules. This leads to errors in spelling, punctuation, and diacritics, which weaken linguistic reliability and sometimes create ambiguity. For example, the word puno without any diacritics can either mean tree or full, depending on the context. This tool matters for several reasons. First, standardized tools promote linguistic consistency in Filipino writing across formal domains, such as in the academe and government publications. Second, enforcing KWF rules supports the integration of standardized spelling into NLP applications, which is vital for digital communication. Next, this contributes to cultural preservation by ensuring that Filipino orthography is respected in technology. This tool also supports SCG4 quality education by improving Filipino learning resources and also SCG10 reduced inequalities by increasing digital access for an under-resourced national language. This tool also has the potential to provide a foundation for larger corporate development and future NLP tools in Filipino. Our objectives are to first develop a rule-based Filipino spelling checker aligned with the Komisyon sa Wikang Filipino's orthographic rules. This will be implemented using Language Tool, an open-source framework for grammar and style checking. Next is to restore proper diacritics in Filipino words to resolve ambiguity. This will be done using a machine translation model trained to automatically add diacritics by learning from parallel pairs of undiacritized and diacritized text. For example, pasa means to give, pasa means to pass or not fail, and pasa means bruise. By restoring proper diacritics, these words can be properly given context. More broadly, our objectives are to improve the reliability of Filipino NLP tools by enforcing orthographic consistency while preserving cultural identity by enforcing standardized Filipino orthography in digital tools. Our system consists of two main components. The first component is the Filipino rule-based spelling checker. So first, the user inputs raw Filipino text, which is then processed by the XML-based rules of the Filipino spelling checker, based on KWF orthographic rules. Formal documents will be used to inform us in our rule development in Language Tool. The corrected output from Language Tool is then used as input for the second part of the pipeline, the diacritic restoration module. This diacritic restoration module uses a machine translation model trained on a parallel corpus of undiacritized and diacritized sentences. By learning these pairs, the model can predict the correct diacritic placement in context. This parallel corpus will be compiled from publicly available formal sources such as edited textbooks, academic essays, and linguistic references. Additional annotated corpora will be requested from the Komisyon sa Wikang Filipino if available. The final corrected output will be KWF compliant text with restored diacritics. In this sample input, there are two intentional errors. Buhay without diacritics could either mean life or alive, while the highlighted text araw-araw could be misinterpreted as independent words. When the sample input is run through the pipeline, we expect to see KWF compliant text as seen in the highlighted text araw-araw, which now follows the hyphenation rule, with restored diacritics as seen in the word buhay, which now means alive. For measuring effectiveness, we plan to do three things. Expert review of detected and corrected words for KWF compliance. We will do this with KWF experts and those familiar with the orthographic rules. And we also do error analysis against the gold standard annotated dataset and user testing with educators, writers, and language professionals. For the performance metrics of the spelling checker, we separate evaluation into detection metrics and correction metrics. So for detection, how well the system identifies orthographic errors, and correction metrics, how accurate and reliable suggestions are. Then for the diacritic module, we rely on the blue score, the word error rate, and diacritic error rate.